Hi, this is Mr. Chu and you are welcome to my study room. Today's study is a continuation of my last study on forming algebraic expression, and we are going to form linear equations from word problems. Let's go straight into the lesson. Thank you. Before we start the first question, let me just remind you once again that all the basic things we need for today's study are already in my video on forming algebraic expressions. So this is just a continuation of that. In case you don't understand anything, you just have to go back and watch the video on forming algebraic expressions. And don't forget to subscribe for more videos. We take question 1 now. 12 plus thrice a number is 42. Find the number. First, let's let the number be x. So thrice the number is 3x according to the last video. Then they say 12 plus thrice a number. So that will give us 12 plus 3x. In word problem, is means equal to. So anytime you get is, it means that should be equal to. So it said 12 plus thrice a number is 42. That means 12 plus 3x equals 42. We should find a number. This is now a linear equation. So we just make x the subject. That means 3x will be equal to 42 minus 12, because 12 is positive when it moves, it becomes minus. Then 3x equals 30. We divide both sides by 3. So our x will be equal to 10. That means the number we are talking about is 10. We take example 2. Our example 2 is find the number n such that when 1/3 of it is added to 8, the result is the same as when 18 is subtracted from 1/2 of it. Here, we have been given what we should call the number already, that is n. So we don't need to let the number be equal to anything again. Then what we just need to find out is 1/3 of it. 1/3 of n, according to our last video, will be 1/3 n, and 1/2 of n will also be 1/2 n. All right. So now the question said when 1/3 of it is added to 8. So 1/3 of it added to 8 means the 8 will come first, then plus 1/3 n. The result is the same. So that is equal to, anytime you say the thing is, it means that is equal to or is the same as, it is equal to. So the result, meaning when we add these two, the result is the same as when 18 is subtracted from 1/2 of it. So that is equal to 1/2 of it first, then minus 18, because they said 18 is subtracted from it. And again, you can just go back and check my video on forming algebraic expressions, and these are clearly stated. So now that we have our equation, our aim will be to make the n the subject. Two things: we can group like terms first, or multiply through by the LCM of the denominators to get rid of the fraction. And I would like to do that first. So the fraction, the denominators are 3 and 2. And the LCM for 3 and 2 is 6. So I'm going to multiply through by 6 to get 6 times 8 plus 6 times 1 over 3n equals 6 times 1/2 n minus 6 times 18. All right. So 6 times 8 is 48 plus the 3 will go here, 1 goes here, 2. So 2 times 1 will give us 2n equals 2 goes here, 1 goes here, 3. 3 times 1 will give us 3n minus 6 times 18 is 108. Good. Now that we have eliminated the fraction from it, or we have gotten rid of the fraction, we can now group like terms and solve. So here, this is 2n, this is 3n. If I bring the 3n here, it will be 2n minus 3n, giving us negative n. I don't want to work with negative n, I want a positive n. So I'll group the 2 rather here, so that I'll get 3n minus 2n to give us a positive number. So I'll group the constant to the left hand side and the numbers with the variables to the right hand side, so that I don't have negative. So that's going to give me 48 plus 108, because it was negative there, equals 3n minus 2n. This will give me 156 being equal to n. Therefore, n equals 156. And that becomes my answer. N equals 150. So 156 is the number you are looking for. Let's take another example. Example 3 is find two consecutive integers such that 5 times the small integer added to 3 times the greater integer equals 51. We don't know the numbers, but all we know is that integers are whole numbers or counting numbers. They increase by 1. You need to add 1 to the previous one to get the next one. Those are integers. So since we don't know them, but they said they are consecutive. Consecutive means that they follow. From one you go to the next one. You cannot jump to the next one. That means they are consecutive. But we don't know them. So we let the first integer be x. If the first integer is x, it will just mean that whatever we have as the first one plus 1 will give us the next one. So the next one will be x plus 1. Good. And this application, since I will not have the time to work all other questions like this, if the questions are consecutive numbers, we just have to find a relationship between consecutive numbers. For example, if the numbers are even numbers, then if the first one is x, the second one will be x plus 2, because even numbers increase by 2. If the numbers are odd numbers and the first one is x, the second one will be x plus 2, because odd numbers also increase by 2. When you get to 1, you just need to add 2 to it to get the next one. They are consecutive numbers, and any other description. So I just want to chip that in quickly, since we cannot solve all questions in one video. Then back to the question. Find two consecutive integers such that 5 times the small integer. So that will be 5x, because the small one for the from the two of them, this will be the smaller one before we get to the second one. Such that 5 times the small integer added to 3 times the greater integer. So 3 times the greater integer will be 3x plus 1. And remember to put the x plus 1 in parentheses, because when opening it, the 3 must multiply everything in it. So if you don't put it in parentheses, the 3 will multiply only the x and it will make your answer wrong. because it's the two of them together that is the second integer. So added to 3 times the greater integer equals 51. Now we are going to form that equation now. That means this is added to this. So this will come first. We have 3x plus 1, then plus 5x, because they said 5x is added to this and is equal to 51. Now we have formed our equation. After forming the equation, we just expand and make x the subject. So in expansion, this gives us 3x plus 3 plus our 5x now will be equal to 51. We group like terms. 3x plus 5x will give us 8x equals 51. This one minus 3. So 8x will be equal to 51 minus 3 is 48. Then we divide both sides by 8. And our x will be equal to 6, 8, 48. So our x will be equal to 6. So the 6 is just our x. Now coming back to the numbers, it means that the first number will be 6 and the second one will be 6 plus 1 is 7. Therefore the numbers are 6 and 7. Example 4 is simple. The sum of 3 consecutive odd numbers is 3,339. Find the numbers. I've explained earlier that consecutive odd numbers increase by 2. So if we let the first number be x, then the second one will just be the first number plus 2, and the third one will be the second number plus 2, which will give us the first number plus 4. So x plus 4, because it will be x plus 2 plus 2, and the 2 plus 2 will give us 4. So these are our 3 numbers. Then they said their sum is 3,339. Sum means addition. X plus 2 plus x plus 4 should give us 3,339. We group like terms. X plus x is 2x plus another x is 3x. Then 2 plus 4 is 6, so 3x plus 6 equals 3,339. Good. Then we group like terms. 3x will be equal to 3,339 minus 6. That will give us 3x equals 3,333. We divide both sides by 3. Then this will give us x equals 1,111. Therefore, the numbers are, the first one, which is x here, will be 1,111. And 1,111 plus 2 will be 1,113. Then 1,111 plus 4, 1,115. So these are our 3 numbers we are looking for. We take another example. Question 5 is, Abraham is 3 times as old as Sylvia. In 8 years' time, Abraham will be twice as old as Sylvia. How old is Abraham? here they gave us information about the ages of two people, but then there is a relationship between the ages, so we don't have to let the two ages be two different variables. That will make it a little more difficult for us, but rather we link the two ages. So the question is saying that Abraham is 3 times as old as Sylvia. It means that if we know Sylvia's age, we just multiply Sylvia's age by 3 to give us Abraham's age. So that's what we are going to do. But unfortunately, we don't know Sylvia's age too. So we let Sylvia's age be, say, Y. So if Sylvia's age is Y, then it means Abraham's age will be, Abraham's age will now be, this is 3 times Sylvia's age, so it will be 3y. Abraham's age will be 3y. Good. Then the question moves on to say that in 8 years' time, Abraham will be twice as old as Sylvia. But we have to find their ages in 8 years' time. Sylvia's age in 8 years' time will be her age now plus 8. And Abraham's age in 8 years' time will be his age now plus 8. So that's just what we are going to do. So in 8 years' time, Sylvia will be Y plus 8 years. Yeah, so 8 years will be added to her age now. And Abraham will be 3y plus 8 years. Let's go to the relationship between them now. In 8 years' time, Abraham will be twice as old as Sylvia. So that means Abraham's age in 8 years' time will be 2 times Sylvia's age in 8 years' time. That means you are going to have 3y plus 8 because that's Abraham's age in 8 years' time. And that will be twice. Twice is 2. 2 times Sylvia's age. So that is y plus 8. Sylvia's age in 8 years' time. So this is our equation, and then we just go ahead and solve for y. So 3y plus 8 will be equal to 2y plus 16. We group like terms. 3y minus 2y equals 16 minus 8. 3y minus 2y is y. 16 minus 8 is 8. Who is y? That means Sylvia is 8 years old now. But the question is, how old is Abraham? Therefore, Abraham is 3 times 8, which is equal to 24 years old. And that is it. So ours is for us to read the question well and extract the very vital information from it to form our equation. Let's take one more example. Question 6 is, a woman is 6 times as old as her daughter. 3 years ago, she was 11 times as old as her daughter. Find their present ages. Again, here there is a link between the woman's age and that of her daughter. She is 6 times the age of her daughter, meaning that if we know her daughter's age, we just have to multiply it by 6 to give us her age. And that is what we are going to do. So we let her daughter's age be, let's say, M. If the daughter's age is M, then the woman's age will be 6M. That is not the only information given, Another set of information given is that 3 years ago, she was 11 times as old as her daughter. That means we need to find the daughter's age 3 years ago as well as the woman's age 3 years ago. Then we establish the relationship between them. And this one, unlike the example we just solved, which is 3 years later or after, this is rather 3 years earlier. So we have to subtract 3 from each of them, their ages now. Then that will give us their ages 3 years ago. That means that the daughter's age 3 years ago will be m minus 3 years. Is that not so? So let's write that. Good. And the woman herself, her age 3 years ago will be 6m minus 3. So we can write that one as well. Good. Now that we have this information, we can now go back to the relationship between the two ages 3 years ago. So 3 years ago, she was 11 times as old as her daughter. So that means 3 years ago, 6m minus 3 will be equal to 11 times. So 11 times m minus 3, which was the daughter's age 3 years ago. Then now we go ahead and solve the equation. 11m minus 33. We group like terms. Mostly, I don't want my m to be negative, so I will move the 6 here instead of bringing it here. Though you can do and divide through by negative 5, there will be no problem. But I want this thing to be positive, so I will get negative 3 plus 33. That will give me 11m. This one move here minus 6m. So 30, negative 3 plus 33 is 30. Will give me 5m. Divide both sides by 5. So 6 will be equal to m. And that is not all. So that means that the daughter's age right now is 6 years. And the woman's age will be 6 times 6, so 36 years. So we should conclude, since the question said we should find their present ages. Therefore, the woman is 36 years old and her daughter is 6 years old. Good. But it is always advisable to pick your final answers and fix them back into the sentences to see whether it makes sense. Let's fix it in and see. We already said that the daughter's age is 6 years and the mother's age is 6 times 6, which is 36. So 3 years ago, it means that the daughter was 6 minus 3, that is 3 years old. Let's check whether the woman's age will be 3 times 11, which is 33. So now that the woman is 36 minus 3 will also give us 33, which is 11 times 3 years, which is the woman's age. That makes our answer correct. So anytime you are given, after solving for the missing numbers, fix them back into the word problem and see whether it makes sense. If it does, then obviously your answer is right. I think with these 6 examples, you can form your own examples and add them up to the ones that will just come after this, so that you share your experiences with me. Thank you for watching and see you next time. Get ready for those questions now. Feel free to pause the video and work them one by one, and you can share the answers with me in the comment box. Thank you. Alright, this is where we end today's lesson on forming linear equations from word problems. And I hope the way I solve these questions will be of help to you the next time you are solving word problems. Feel free to share, comment with me. And I want to encourage you once again to subscribe to this channel for more videos if you haven't done that yet. I hope to see you another time in my study room for more lessons. Thank you for making time with me, and see you next time. Bye bye.